I am converting the whole chapter light into the form of question and answer, and this is part 2. In this part, we are focused on the image formed by a convex lens. And for this, I want to start with the rule which I told you in part 1. Look at this. Write down the rule of refraction of light through a convex lens with diagram. If it is so, then it will be better to have a diagram. Looking at this first diagram, we can say that light ray coming parallel to the principal axis passes through focus after refraction. And this is one of the rule. A ray of light parallel to the principal axis of convex lens passes through the focus after refraction. Now look at this second one. A ray of light is shown which is passing through the optical center and passes undeviated. This is another rule. A ray passing through the optical center emerges without deviation. And there is third rule also. A ray of light which comes through the focus and when falls on the convex lens, it refracts being parallel to the principal axis. This can be represented this way. A ray passing through the focus and incident on the lens after refraction emerges parallel to the principal axis. This third rule is actually just opposite of the first. That's why normally it is not used. We are using this first rule and second rule for the formation of image by a convex lens. Convex lens forms different types of image. Now, how many types of image will a convex lens forms? Write down conditions for the formation of those types of image. This is one question. There are actually a convex lens can form 6 different types of image, and these images forms when the object is in the following distances in front of the convex lens. According to the distance of the object from the convex lens, different types of image is found to be formed by convex lens, and this is analyzed and lastly declared that a convex lens can form 6 different types of image. In which condition what type of image is formed can be represented diagrammatically. I want to start first with the information only. When object is at infinity, we can draw a ray diagram when object is lying at infinity from convex lens. It can be understood this way also. Let's say this is a convex lens and object is at infinity. It means object cannot be shown. This is first condition. For this, we'll put the object at infinity and we'll draw the ray diagram to show where and what kind of image a convex lens forms. Now second, when object lies beyond 2f, it means now object can be shown in the diagram this place. And when we put the object at this place, what type of image it forms? We'll draw another ray diagram. Now third, when object lies at 2f, when object is taken a little nearer, at 2f, then what kind of image forms? That can be drawn and can be shown with another diagram. And when object lies between f and 2f, so somewhere between f and 2f, if object is at this place, this is fourth condition, what kind of image will be formed by the convex lens? We'll draw this also. And when object lies at focus, focus means we'll put the object at this place and we'll draw another ray diagram. And when object lies between f and o, we'll put somewhere here and we'll draw another diagram. This way, taking object in different position, we are going to draw ray diagram, and there are 6 different conditions and 6 different types of image a convex lens forms. Okay, let's start with first. Draw a neat diagram to show the formation of image by a convex lens when object is at infinity from the lens. Then what we do first we'll draw lens and we'll bisect it and we'll draw principal axis and we'll make focus in equidistant from the optical center. It is denoted by capital F, and we'll point out 2f which lies at double distance than that of the focus, and this is optical center. This much is same for each and every diagram. But our object is at infinity, we cannot show this object. We have to draw the ray diagram in such a way that the light ray coming from the object is converged by this convex lens, and where they intersect with each other, image forms at that place. Since object is at infinity, when we turn convex lens towards infinity, then the ray of light coming from the object can be considered to be parallel with each other. First ray will draw parallel to the principal axis. It passes through focus this way. Another ray also we have to draw, which is coming from the object, and it also passes through focus. These two are the rays coming from the object, and after refraction they are intersected at focus. It means image forms at focus, but image is so small that it cannot be seen clearly here in the diagram. Now if we have to write the nature of image, we can write image is real. Why real? Because really the refracted rays are intersected at focus and image formed at that place, and so image is real. Now second, image is inverted. The real image is normally inverted, and in this diagram only we will not be able to see the inverted image. In another diagram we can see the inverted image clearly. Image is highly diminished. This is very small than that of the object, that's why it is highly diminished. Where the image form, position of image forms at focus on the either side of the lens. We can write the meaning of the symbol also. F is focus, O is optical center. Okay, next, draw a neat diagram to show the formation of image by a convex lens when object lies B1 2F from the lens. Now second condition, for this we have to plot the lens and we'll bisect it with dot line. We'll plot this principal axis and focus and then 2F and optical center. Till this in all the diagrams same, but now our object is B1 2F, means somewhere here, and this object can be named as AB, and we are going to draw its image. For the formation of image, we have to remember that we'll draw two rays of light coming from the object, and after the refraction, where they meet, image forms at that place. That's why I want to draw one ray of light from the head of the object. It is parallel to the principal axis. It passes through focus. Now another ray I want to draw from the same head, and it is passing through the optical center, passes straight and intersected at this point. It means the ray of light coming from the head of the object is intersected at this point. That's why head forms at this point, and that's why image is inverted. Okay, now we can write the name of the image also. Object is AB, its image is A dash B dash. Now nature of image. Image is real because really the refracted rays are intersected and image formed. That's why image is real. Image is inverted, it is clearly seen in the diagram. It is inverted, and image is diminished. It is smaller than the object. That's why, look at this, is smaller than the object. That's why image is diminished. Next, position of image, where it formed. Image forms between focus and 2F on the either side of the lens, and we can write the meaning of the symbol also. F is focus, O is optical center, AB is object, and we can write A dash B dash image also. Okay, next, this is third condition. Draw a neat diagram to show the formation of image by a convex lens when object is at 2F of the lens. First we have to draw the lens, bisect it, principal axis, focus and 2F, and then optical center. Now our object is at 2F. We can draw two rays of light from the object. From the head of the object, a ray of light is drawn which passes through focus, because the ray of light parallel to the principal axis passes through focus. Another ray can be drawn from the head passing through the optical center, and these two rays after refraction are intersected at this point. It means image forms at this place. Since the ray of light coming from head is intersected at this point, that's why image becomes inverted like this, and image can be named as A dash B dash. Okay, nature of image. Image is real because really refracted ray are intersected and image formed. Image is clearly inverted, and image is of same size. What is the size of AB? The same size is of A dash B dash. Now what is the position of image? Image forms at 2F on the either side of the lens. We can write the meaning of the symbol used in the diagram also. F focus, O optical center, AB object, A dash B dash image. Okay, let's go to next. Draw a neat diagram to show the formation of image by a convex lens when object is in between 2F and F of the lens. We are taking object nearer and nearer to the lens. This is lens and principal axis, focus and 2F and optical center. Till this same thing, but our object now lies between F and 2F, somewhere between F and 2F. Now, a ray of light coming from the head of the object passes through focus, and a ray of light coming from the head of the object is shown to be passing through optical center, and they are intersecting at this point. They are intersected at this point. That's why head goes down to this point and image becomes bigger than the object. Okay, the image can be named as A dash B dash. Now, nature of image is real, image is inverted, it is clearly seen, image is magnified means it is bigger than the object AB. Okay, now position of the image, where it formed, image forms B1 2F on the either side of the lens. We can remember this: if object lies B1 2F, image forms between F and 2F. If object lies between F and 2F, then image forms B1 2F. Okay, now meaning of the symbol used in the diagram: F focus, O optical center, AB object, A dash B dash image. Okay, next. Draw a neat diagram to show the formation of image by a convex lens when object lies at focus of the lens. We can draw the lens, bisect it, and focus, and then 2F, and then optical center till this. Same thing for each of the diagram. Now our object is at focus. A ray of light coming from the head of the object is shown to be passing through the focus, and another ray, when passes through the optical center, appears to be passing straight. Now this is a little twist. Here both the rays seems to be parallel to each other, but exactly they are not parallel. When they are drawn to sufficiently long distance, then they are actually coming closer to closer, they will meet at infinity. That's why image forms at infinity, we can see this way, because it cannot be drawn on the paper because the light rays goes up to the infinity. Okay, what is the nature of image? Image is real because these two rays meet at infinity and image forms. Refracted ray really intersect with each other and image formed. That's why image is real. Image is inverted and image is highly magnified. We can remember one another matter also. If object is at infinity, its image forms at focus, which is highly diminished. But if object is at focus, its image forms at infinity, which is highly magnified. Position of image. Where image forms at infinity on the either side of the lens. Okay, F means focus, O optical center, AB object, A dash B dash image. Now this is last condition. Draw a neat diagram to show the formation of image by a convex lens when object is in between focus and optical center of the lens. This is lens, bisected, principal axis, focus, and 2F, and then optical center. Till this is same. Now object is placed between F and O. It is named as AB. A ray of light coming parallel to the principal axis from the head of the object passes through focus. Another ray passing through the optical center passes straight. But here also a little twist. These two rays are diverging rays. They are moving away from each other. They never meet in the really refracted direction. That's why I'm going to draw them in opposite direction, where really light is not refracted but image forms in the opposite direction. So I'm going to draw a dot line from the first ray, refracted ray of light, and second dot line from the second refracted ray of light. This dot line meet at this point. What it means? This produced ray meet at this point means image forms at this point. Since light ray coming from the head is intersected at this point, so head forms at this place and will be able to see the image at this place. This image is virtual because really refracted rays of light is not reaching up to the image, but this image can be seen with naked eye and it cannot be obtained on the screen. That's why this is virtual, because really refracted rays are not reaching up to the image, can be seen but cannot be obtained on the screen. Okay, now how can we name it A dash B dash? If object is AB, image is A dash B dash. Now nature of image is virtual because really light is not reaching up to the image. Image is erect, it is seen erect or upright. Image is magnified, yes, it is bigger than the object. And position of the image, where image forms on the same side of the lens. And we can write the meaning of the symbol also. F is focus, O is optical center, AB is object, A dash B dash is image. These are 6 different conditions and 6 different types of image formed by the convex lens. Any one of these can be asked in the examination. That's why in the point of view of examination also these diagrams are very important. Okay, now I'm going to finish this class, and in another class we'll continue with the same convex lens. Okay, this much for today.